Hey, what's up, GRE lovers? Today, what we're gonna do is we are going to look into a ratio problem. And this was one of the requested problems. As you can see that I have not typed this problem in. I just simply just cropped the image and pasted in because I was kind of bit lazy. So anyways, so we're talking about ratios and the fact that they're not really same as fractions. They are similar, but they are a bit different. And before actually diving into this ratio problem, I think we need to have a firm understanding of what basically ratios are and how do they basically work and how they're actually different from the fractions. So before diving into this, let's just quickly review what fractions are and how they're different from the ratios. So if we're talking about fractions, I'm interested in the part over the total. Whereas when I'm talking about the ratios, I'm interested in what is the relationship of part 1 with the part 2 when part 1 and part 2 combine to give the total sum. So if I want to give you examples of fraction, a classical example that I can give here is, let's say there is a pizza and there are total 8 slices, and let's say I'm interested in getting half of that. Let's say I'm super hungry, and what I do here is multiply 4 on the bottom and the top, and what I get here is 8 and a 4. So what this really means, what this half basically means, is that I'm interested in getting 4 slices out of the 8 slices, which is the total. And I can give you a very quick another example. Let's say that you're trying to sell your property through a property dealer, and let's say the property dealer is asking you that, hey, I want a 1/4 part of the profit of the selling price. And let's say the original price that the plot was sold was 100. So all I'm going to do is multiply 25 on the both sides. What I get is 25 over the total, which is the 100. So this is basically the amount that the property dealer is asking for as his fair share. So now that we are done with a quick overview of what fractions are, I think it's time to shift to the ratios and probably try to understand how do they work. So I'm going to give you a simple example that what ratios are and why do we need them at the first place. So let's say that I live with my parents, and on daily basis I make 3 cups of tea, and I add 6 teaspoons of sugar. And this is something which is my normal routine is, and I'm pretty much confident that, hey, you know what, this tea is gonna taste really awesome. But out of nowhere, let's say I got a promotion and I received 12 guests. Okay, probably they are my friends or coworkers or whatnot, and I'm panicking. I'm like, OMG. And I'm panicking like, what? And let's say I have no experience in making tea for these many people, and I'm panicking and I don't know what to do. So in these type of problems, the need of the concept of ratio was born, and therefore ratio came to the rescue. So if I can simply arrange cups to the amount of sugar with a relationship with part 1 and part 2, I can say, okay, so for 3 cups of tea, I'm adding 6 teaspoons of sugar. What would be the case for 1 cup of tea? So basically what I'm doing here is dividing 3 on the both sides, and then I'm gonna get 2. So every 1 cup of tea requires 2 teaspoons of sugar. Now the question is, since I'm interested in 12 cups of tea for 12 guests, all I need to do is, okay, 12 cups of tea, and how many amount of sugar that I really need to add in. So if I look at the previous relationship right over here, so 1 cup requires double amount of teaspoons of sugar. So what's going to be the double of 12? It's going to be 24. So this is a very simple example that I'm pretty much sure that you can all relate to. In reality, ratios are used in material science engineering in alloys. They are used in industries like synthetics. They're also used in medicines, cooking, etc., etc. So the bottom line is ratios are all over us. It's really common that we are using ratios in our daily basis. So now that we have a pretty good understanding of what ratios are, let's jump to the question and try to see what the question is asking for. Okay, here it goes. Among the students, if boys and girls are in the ratio of 2 to 3, okay, so there's a ratio of boys over the girls, and it is 2:3. Okay. And for every one teacher, there are 10 students. Okay, so there is another ratio, which is like, okay, so for every one teacher, so the teacher with the ratio of students, one teacher, the ratio of student is 10. This is the second relationship which is given to me. And then it says, whereas for every 4 male teachers, okay, now we're into male teachers over probably what, female teachers, yeah, female teachers. The relationship is for every 4 male teachers, there are 5 female teachers. And which of the following is the ratio of number of boys to the number of male teachers? So the question is basically interested in if this is the relationships given, so what is the relationship between the boys and the male teachers? So if I come down here, I have done a simple analysis in which basically, just to save time, in which I have written all of these relationships in just one simple line. And let me try to explain what these really mean. So when you combine boys to girls, you get a total of S, which are the total students. So if there are 2 boys and 3 girls, and the total is going to be 5. If you come back here, I have mentioned that ratios are part 1, part 2, and you combine them to get the total. And then it gives me, this is like the first relationship in which I've combined the total. The second relationship is over here, in which it says that, you know what, for every 1 teacher, I have 10 students, okay? And then the final relationship is, okay, so for every 4 male teachers, I have 5 female teachers. And if I combine the sum here, 4 plus 5 is 9. So now that I am basically done in arranging these values, now the question is, how do I get the relationship between male teachers all the way to the boys? So first of all, what you need to do is we need to come up with a common ground reference, the common total. And the only way we can do that is basically use this ratio right here, the middle one, to get the common ground for S and the common ground for the total number of teachers. And how do we do that? Well, first of all, we need to kind of like make it as much similar. So if I want to use this ratio right over here, and if I want to jump from 5 all the way to 10, what I can do is basically multiply the whole ratio, the first ratio, with a 2. And I can just get down here and I'm like, okay, since 5 times 2 is 10, which are going to be the total students, and then 3 times 2 is going to be 6 girls, and another 2 times 2 is going to be 4 boys. So I have basically, what I've done here is just to make this ratio, the total ratio of students, comparable to the total ratio of with the teachers. I have done is I have multiplied the initial ratio with the 2. And now I can compare the initial total boys ratio, which was 10, to the total number of teachers, which is 1. The problem here is that, the total ratio which is given by the question is 9. And my next attempt is going to be how I can make this 1 a 9. So all I have to do is multiply all of this with 9. And if I start multiplying, I'm going to get 9 total number of teachers all the way here. Then I'm going to get 90 total number of students. Then I'm going to get 6 nines are 54, which are going to be the number of girls. And then the boys are going to be like 4 nines are 36. Okay, so now that the relationship with the total number of teachers and the total number of students are comparable, I can just simply slide these down as it is without any change, okay? And now I can basically compare the male teachers, which are 4, and the boys, which are 36. And since the ratio is asking me, okay, so what is the ratio of boys over the male teachers? So, well, boys are 36, right? And the male teachers are 4. So I can do a simplification. I can say, okay, 4 times 9 is 36. And this is going to be the ratio that I will be looking for. So if I scroll back up right over here, the answer is E.